Chapter 2, Linear Correlation. This chapter will be of 12 marks. One MCQ, one one VSQ, one 2 marker, one 3 marker, and one 5 marker will be asked from this chapter. Basically, whatever you have studied in your 11th, like mean, standard deviation, its application will be done over here. So first of all, we must understand what is correlation. When two variables are the statistical measure, the values of which will change frequently, they are called variables. They are having quantitative characteristics, and qualitative characteristics is known as attributes. So when two variables are associated with some cause and effect relationship, the cause and effect relationship is a factor which will lead to change in one variable due to change in other variable. For example, price and demand. As you know, when price increases, demand decreases, and vice versa. Amount of rainfall and production of crop. Rainfall increases, crop production will also increases. Number of hours put in your studies and marks you obtain in your examination. So there has to be some relationship between these type of variable which will lead to change in one variable due to change in other variable. These change may be in the same direction or in the opposite direction. It may happen. If one variable increases, the other will decreases, or if one decreases, other will increases, or it may happen if one increases, the other will also increase. If one decreases, the other will also decrease. The change may be in the same direction or maybe in the opposite direction. But the bottom line is that these two variables must have been associated with some sort of cause and effect relationship. So if there are simultaneous changes in the values of two variables due to direct or indirect cause and effect relationship, then it is called correlation between two variables. So this is correlation. This is the meaning or definition of correlation. Now, linear correlation. The correlation is said to be linear if the points plotted on graph paper corresponding to the ordered pairs of two variables are on a line or nearer to line. Or you can say, if the relationship between two variables can be established through a linearity by plotting their values on a graph paper, it is called linear correlation. There are different examples also, like radius and circumferences of the circle, demand and price and supply, sales and profit, amount of advertisement and turnover. So all these variables are associated with some sort of cause and effect relationship. That's why they are correlated. Correlation is just a quality. It is just a characteristics. The exactness or the measure which will define how closely two variables are correlated is known as correlation coefficient, which is denoted by R. correlation coefficient is a measure which will describe the closeness or nearness of two variables. To which extent the two variables are correlated. That can be found out with the help of measure, which will give you certain specific number, that is called correlation coefficient. The first idea of linear correlation and its measure was given by Carl Pearson. Now, there are different methods of studying correlation. In your syllabus, there are three methods: scatter diagram method, or you can say graphical method, Carl Pearson's product moment method, and Spearman's rank correlation method. Scatter diagram method. Under this method, different values of x and y are plotted on a graph paper on x-axis and y-axis, and on the basis of that we can have idea about the direction of correlation between two variables. So on the basis of that we can have broadly 5 types of correlation between two variables. For example, if you will plot all the points and you will get these type of line. Then the value of R, correlation coefficient, will be +1. It is called perfect positive correlation. So here the change will be in the same direction, in the same proportion. If value of x increases by 2 units, then value of y will increase by 4 units, for example. If value of x increases by 4 units, then value of y will increase by 8 units. So the change will be in the same direction, in the same proportion. So all the points will be on a line. That's why it is known as perfect positive correlation. Value of correlation coefficient will be always between -1 to +1. That is for sure. It cannot be less than -1. It cannot be more than +1. So here it is perfect positive correlation. Change in x will lead to change in y in the same direction, in the same proportion. Now, second type. Here the change will be in the same direction but not in the same proportion. The point may or may not lie on the same line. So graph will be like this. All points will be nearby straight line but not on the same line. So here value of correlation coefficient will be between 0 to 1. So that is called partial positive correlation. Now, the change will be in the opposite direction in the same proportion. So here value of R will be -1. It is called perfect negative correlation. In this case, increase in value of X will lead to decrease in value of Y, or increase in value of Y will lead to decrease in value of X. The change will be in the opposite direction and in the same proportion. So you will get all the points on the same line but in negative order, like demand and price. So that's why it is known as perfect negative correlation. Here the change will be in the opposite direction but not in the same proportion. The points corresponding to values of X and Y will not lie on the same line but they will be scattered near the straight line. So here value of R will be between -1 to 0. This is called partial negative correlation. In practical life, perfect positive or perfect negative correlation rarely exist. No two variables are perfectly correlated. There can be partial relationship like price and demand. If price increases, demand increases, but it cannot be always in the same proportion. Then partial positive, price and supply. Price increases, supply increases. This cannot be also in the same proportion. It will be in the same direction. So in practical life, the correlation between two variables will be partial positive or partial negative. Or it may happen that two variables are not associated at all. There is no correlation between two variables. Like number of hours studied by me and your result in exam. There is no correlation. You are not going to score marks on the basis of what I am doing, what I have studied. It's totally up to you. So, if these type of variables are there, there is no correlation between them. They are not associated, they are not correlated in any sense. So here values will be like scattered like this. It will not specify any direction. It can be anything. So it is called R is equal to 0. Lack or absence of correlation. See, illustration 1. After standard deduction from total income, 20% income tax is imposed on the remaining income. So whatever you are earning, 20% will be taken by government in form of tax. The information regarding taxable income and tax to be paid is given below for 5%. Income in 1000 rupees and income tax in 1000 rupees. Okay, when the income was 50,000, tax was 10,000. Income was 30,000, tax was 6,000. Income was 80,000, tax was 16,000. Income was 20,000, tax was 4,000. Income was 1 lakh, tax was 20,000. Now, draw a scatter diagram from this information and discuss about its correlation. Now, if we will plot this value on a graph paper, on x-axis income, on y-axis income tax. So, when x is 50, y is 10, this. Then when x is 30, y is 6, this. When x is 80, y is 60. When x is 20, y is 4. And when x is 100, y is 2. So you can see here all points are on the same line. Because income is taxable at 20%. So what will be your income? Then 20% of it will be charged at tax at every time. So they are perfectly related. So here value of R will be +1. So this is called perfect positive correlation.
Sir,
See, to know the correlation, to know the relation between monthly expenditure and monthly savings for middle class families, The information regarding expenditure and savings for 5 family is given below. Monthly income of each family is 20,000. So expenditure and savings. If expenditure was 15,000, savings was 5,000. If expenditure was 18,000, savings was 2,000. If expenditure was 8,000, savings was 12,000. Expenditure was 10,000, savings was 10,000. Expenditure was 12,000, savings was 8,000. By plotting all this value on a graph paper, we will get these type of graph. So here also you will get all the value on the same line. So this is perfect negative correlation. A company manufactures ready-made garments. The monthly advertisement cost in 10 lakh rupees and sale of garment. So you can say how much amount spent by company on advertisement and what will be the sales of garment that has been given. You have to draw scatter diagram and you have to discuss about it. Let's do this. So on x-axis advertisement cost in 10 lakh rupees. On y-axis sale of garment in crore rupees. Now maximum value of x is 50. So we can take 1 centimeter is equal to what accordingly. So with 2, 4, 6, 8, 10, 12, 14 and 16. Maximum value of y is say 70. So we can take 1 centimeter is equal to 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65 and 70. When value of x is 5, value of y is 20. When value of x is 8, value of y is 30. Then value of x is 10, value of y is 50, 15 and 70. 12 and 60 and 9 and 35. So these type of graph is obtained by plotting all the values of x and y on the graph paper. Here you can see the direction is increasing, but it is not in the same proportion. All the points are not on a straight line. So you can say this is the case of partial positive correlation, where value of R will be between 0 to 1. Increase in price will cause decrease in demand, because demand and price are inversely related, that we have established in your 11th standard law of demand. But here also the change is in the opposite direction and not in the same proportion. So it is a case of partial negative correlation, where value of R will be between -1 and 0. Now, merits and limitation of this method. This is the most simple method, simplest method to know the nature of correlation. Not much more statistical or mathematical knowledge is required. It is easy to understand. It will give you clear idea about the strength and direction of correlation between two variables. By looking to the graph, you can easily say whether the two variables are correlated or not. What is the direction of their correlation? There is no difficulty in judging the nature of correlation even if some observations are missing. You don't have to carry out any type of calculation. But the main limitation is that it will give the idea about nature and direction about correlation, but will not provide exact measure of correlation. If I'll say there is partial positive correlation, then value can be between 0 to 1. It can be any number. 0.1, 0.2, 0.99, 0.89, 0.75, 0.68, any number. It will not give you the exact degree of correlation. It will not say anything about correlation coefficient. Its exact value cannot be determined. That is the main limitation. This is often asked in your exam. Okay, what is the main drawback or limitation of scatter diagram method? Now, Carl Pearson's product moment method. This is the most important one. From this method, the sums will be asked generally 2 mark and 5 mark. This method will also be helpful in your third chapter. So your second chapter and third chapter are interrelated. If you are able to solve second chapter, then and then only you will be able to understand the third chapter. Now, on the basis of his study and research, Carl Pearson derived a formula for correlation coefficient between two variables. He defined correlation as a ratio of covariance between x and y and standard deviation of x and y. He has given numerous formulas. Basically 6 to 7 formulas are there almost. In your textbook, there is no specification which formula is to be used when, but I will give you a hint. You should always follow it. So whenever there is no specification in the sum, you should apply a formula according to particular situation, because it is expected, even though they are not specified, that you use certain formula in certain sum. It is expected that you know when to use which formula, even though the answer will be same by using any of the formula. When observations are small, observation means value of x and y, generally less than 30. Then this formula will be used. R is equal to n into sigma xy minus sigma x into sigma y upon 2 square roots. In first square root, n into sigma x square minus sigma x whole square. In second square root, n into sigma y square minus sigma y whole square. So if in your sum, it will be given like this, x and y, then you have to prepare another 3 column, x square, y square and xy. Total of this is sigma x, sigma y, sigma x square, sigma y square and sigma xy. Then next one. Observations are large, but x bar and y bar are integer. X bar means mean of x, that is sigma x upon n. N means number of observation. Y bar means sigma y upon n. So in this case, you should apply this formula. Sigma x minus x bar into y minus y bar. Upon square root sigma x minus x bar whole square into y minus y bar. So your table in this type of sum. Okay, this is x, this is y. So first of all, you will find out sigma x, sigma y. From that you will find out x bar and y bar. Now from each value of x you will subtract x bar. From each value of y you will subtract y bar. Total of this column is going to be 0 because sum of total of deviation taken from mean is always 0. So even if you don't do the total, it is going to be 0 and there is no need to do the total. Yeah, you can check it whether your calculation is right or wrong. Then you have to square this out. X minus x bar whole square, y minus y bar whole square and x minus x bar into y minus y bar. This will be your numerator and x minus x bar whole square, y minus y bar whole square. Its square root will be your denominator. Most important formula. for your 5 marks off. This is a modification of first formula. When observations are too large, when observations are non-integer, when observations are fraction, decimal, x bar and y bar are also non-integer, then using first or second formula will be tedious and it will require lots of calculation. So your purpose is to simplify it. So whenever we are getting mean in form of non-integer number, we will take assume mean. So by applying that concept, your first formula will be revised. N into sigma uv minus sigma u to sigma v. N into sigma u square minus sigma u whole square. N into sigma v square minus sigma v whole square. So here u means you are subtracting an assumed value from each and every value of x. For example, your x bar is 25.78. So instead of subtracting 25.78, you will subtract 25. You are subtracting nearest figure. And if all the observations are having same class length, for example, all the values of x are divisible by 5, divisible by 10, divisible by 100, then you will divide it. Or if they are multiplied, they can be multiplied 0.1, 0.2, 0.3, then you have to multiply. Your purpose is to simplify the data so that your calculation will be easier. Same way, y minus b upon cy. So x, y, from that u, v, u square, v square and uv. Get total of each: sigma u, sigma v, sigma u square, sigma v square, sigma uv. Then these relations will be helpful in a particular sum which will appear in later part of the chapter. You just memorize. X bar is equal to A plus sigma u upon n, and if it is class length, then Cx. This formula we used in 11. X bar is equal to A plus sigma fida upon n into C. It's the same. For y, it will be B plus sigma v upon n into class length of y. This formula will be used when in the sum value of sigma u or sigma v will not be given. At that time, this relation will be useful. R is equal to covariance of x and y upon standard deviation of x, standard deviation of y. Now they will generally provide the value of covariance. Covariance means sigma x minus x bar, y minus y bar upon n. Standard deviation, you know, you have done in your 11th. For x, x minus x bar whole square upon n, it's square root. For y, now you can see covariance of xy is equal to sigma x minus x bar into y minus y bar upon n. So if I will substitute the value, I will get a new formula. Instead of covariance, it will be sigma x minus x bar into y minus y bar upon n into sx into sy. There is another formula. Sigma xy minus n into x bar into y bar upon n into sx into sy. Now, properties or characteristics of correlation coefficient. As I told you, the value of correlation coefficient will be between -1 to +1. It cannot exceed +1 and it cannot be less than -1. So its value will be always between these two numbers. Correlation coefficient is free from any unit of measure. So if value of correlation is 0.8, you do not have to add kg, liter, meter, gram. It is not related with any unit. It is an absolute measure, free from unit. It's just a number. Then correlation between x and y is same as correlation between y and x. Doesn't matter what is the order. Correlation coefficient does not change with change of origin and change of scale. Means it is not affected by addition, multiplication, subtraction or division. If you are going to transform it, if you are adding same number to all values of x, or you are dividing all the value of x by same number, if you are multiplying with the same number, if you are subtracting the same value from all the observation, but the condition is that whatever operation you are performing, addition, subtraction, multiplication, division, should be performed on all the observation. Then also the answer is going to be unchanged. So whatever formula you are using, answer is going to be same. Then if R of minus x and minus y is equal to minus R, the negative positive there will be change. Okay, minus minus plus 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 minus 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 plus minus. That is the basic thing. So signs of both variable are changed, then sign of correlation coefficient will be unchanged. But if sign of one variable is changed, another is unchanged. Okay, for example, earlier it is xy and now it is minus x minus y, then answer will be minus. If it was xy, now it is minus x minus y, then it will be plus, minus minus plus. If earlier it was xy, now it is plus x minus y, then also answer will be minus.